Hey everyone, here we go with the study guide. I'm going to try and help us get through it. Starting with number 1, evaluate. So for this problem, we need to remember that a fractional exponent means power over root. So 4 is the power or the exponent, and 3 is the root. So we could write that as 27 to the 4th power, take the cube root, or we can write it as the cube root of 27 and then do that to the 4th power. So it doesn't matter which way you approach it. I'm going to stick with, sorry, I don't know why that's coming on. Go away, go away. Sorry. Okay. Anyways, so here, if I do this one, the cube root of 27, break 27 down into 3 times 9. 3 doesn't break down. 9 breaks down into 3 times 3. Those don't break down. I'm looking for 3 of a kind, which I have 1, 2, 3. So a 3 gets out of the cube root, nobody's left inside, and then to the 4th power, and that gives me a final answer of 81. On to the next one. Solve and check for extraneous solutions. And we have a square root, so to get rid of it, I need to square both sides. Square and square root cancel. I have 3x plus 4 on this side, x squared. Since I have x squared and x in the same problem, I'm going to get everything on one side and make it equal 0. So I'm going to move these over to the other side. See? Because I like my x squared to stay positive. So I'm going to move the other guys. So minus 3x minus 4. So I have 0 equals x squared minus 3x minus 4. Then using the x, I would factor, multiply to make negative 4, and add to make negative 3. The numbers that do that are negative 4 and 1. So I have 0 equals x minus 4 and x plus 1. And then set each part equal to 0. And when you solve each of those equations, you should get x equals 4 and negative 1. But the catch is we need to check for extraneous solutions. So go back and plug them in. So if I start with the 4, I have square root of 3 times 4 plus 4 equals 4. 3 times 4 is 12 plus 4. Then I have equals 4. I get square root of 16 equals 4. And 4 equals, oopsie, got ahead of myself there. And 4 equals 4. 4 equals 4. Good. Then I try the negative 1. So I have square root of 3 times negative 1 plus 4 equals negative 1. Right there, you should already know there's an issue. A square root can't equal a negative, but we'll just, whoopsie, continue anyways. So if I continue on, I get square root negative 3 plus 4 equals negative 1. That gives me square root of 1 is negative 1. Square root of 1 is 1, but that does not equal a negative 1. So the only actual answer, this one we would cross out, and the only thing you would see on your final is x equals 4. All right, then this question, find f of g of 3. I'm going to start on the inside and work my way out. The inside says plug in 3 to the g of x function. So I'm going to start with the g of x and plug in 3. So 4 times 3 minus 6. And then I would simplify. That's 12 minus 6, which equals 6. So I have g of 3 equals 6. Then if I look here, this says for the f function, plug in g of 3. Well, I know g of 3 is 6, so I'm going to go to f and plug in instead of, hold on one second. Sorry, so I'm plugging in g of 3 into the f of x function. But since I know that g of 3 equals 6, I'm really just going to plug in 6. So I have 5 times 6 to the negative 1. Here we have to be careful to do the exponent before we multiply. So I would have 5 and then times 6 to the negative 1. 5 has an exponent of 1. Remember, negative exponents mean they're unhappy, and we have a fraction situation. 5 is happy in the top. It's going to stay. 6 moves to the bottom, and that gives us a positive 1 exponent, so we have 5 over 6. On to the next one. This one says take our two functions and subtract. So starting with the g of x function, 2 x to the 3/4 plus 15 y to the 1/5 minus, and then my f of x function, negative 8x to the 3/4 plus 11y to the 1/5. So here, when I go to simplify, I'm going to watch those parentheses real carefully. The first parentheses, I don't really need those, so just rewrite. The second parenthesis, though, I have to distribute that negative through, so I get plus 8x to the 3/4 and then minus 11y to the 1/5. Then it's a matter of combining like terms. So like terms here and here, put those together, I get 10x to the 3/4. And then, let me write that a little nicer, sorry. 10x to the 3/4. Then I go through and combine the other like terms. There we go. And these two are like terms, put those together, and they give me positive 4y to the 1/5. And that's your answer. All right, find an equation of the inverse. This is when we get to do the Freaky Friday switch, but first I need y instead of f of x. Then I would Freaky Friday switch the x and the y, and then solve for y. So add 3 to both sides. Sorry about the funky add sign there. Let's try that again. So add 3. So I have x plus 3 equals 7y to the 4th. Divide both sides by 7. And then 4th root both sides. And I get, sorry. Okay. No, come on, go for it, honey. All right, so I get the 4th root of x plus 3 all over 7 equals y. But on the test, you're going to see that written in function notation. So f inverse of x equals the 4th root of x plus 3 all over 7. All right, forward. Given the exponential function, find the domain and range. So looking for domain going left to right. Even though it doesn't show arrows, since this graph extends beyond the coordinate plane, we assume there's arrows there. So this would be from negative infinity to positive infinity. The range is a bit trickier. We look at the bottom of the graph, it looks like it levels off right here-ish. There's actually an asymptote there where it looks like it levels off, and that comes from the k value. The k equals -3. That's your asymptote. So a horizontal asymptote at -3. So we would actually say from -3 parenthesis, because we can't actually equal -3, and then to infinity. Onwards. Explain the difference between growth and decay. So growth, and we have two different ways to look at it, with an equation and with a graph. So with an equation, the equation we are looking at is y equals a times b to the x. With the growth equation, b is going to be greater than 1. And with the graph, it's going to look something like this going up. Something like that. And then for decay, that same basic equation, y equals a times b to the x. But in this case, b is going to be between 0 and 1, so fraction or decimal. And then for the graph, it's going to go down, something like that. And there you go. All right. And Calvin deposits $300 in an account that earns 4.2% annual interest compounded continuously. What is the balance of the account after 5 years? So I would need to, first of all, it says compounded continuously. Continuously means use pert. And so then I would start plugging numbers in. My principal, or my initial amount, is going to be the 300. E is the number E. Rate is over here. That's your rate, but remember we write it as a decimal, so 0.042 as a decimal. And then the time, it says, is 5 years. So 5 years. Then I would need a calculator, and I honestly do not remember the answer to this one, and I don't have a calculator nearby. So yeah, maybe I'll come back to that in a minute. But that's what you would plug into your calculator. Next one, Ethan invests $700 in stock for Pert Plus shampoo. If the value of the stock decreases at a rate of 1.3% each year, write an exponential model for the value of Y of the stock after T years. So here the directions, our action here is to write the model, which means write the equation. What we're looking for is A times B to the T is the general model. And for this one, since it says decreases, special spelling of decreases, we would be looking at B as 1 minus R. If it was increases or growth, we would do 1 plus R. But this case, decreases, we're looking at decay. So this is 1 minus R. So to actually find B, I would do 1 minus my rate here. Remember, again, has to be written as a decimal, 0.013. So 0.013. So I get B equals 0.987. Then I would write my equation, Y equals my initial amount, which is 700, times my B, 0.987. And then it says in terms of T years, which is T. So that would be your answers, just the equation. Okay. Then rewrite in exponential notation. So, exponential notation. Here we go. So that would be doing the swirly. To change it from one notation to the other, we start with the base always, and we swirly to the right and swirly back to the left. So this would be 5 to what power is 1 over 125. That's the same question that a log asks, basically what power. So 5 to what power is 1 over 125, and you don't have to solve it. That's the answer. Then the next one, to simplify logs, we learned a property for logs that if the base of an exponent and the base of a log match, then we can cancel them. So this cancels and this cancels. The answer is 5. All right, expand. This one, since our overall fraction right here, it means division. Division turns into subtraction. So I would have log 7x squared minus log 3. So we change that division into 2 subtracted logs. Then we have multiplication in that first log. Multiplication will turn into addition. So log 7 plus log x squared minus log 3. And then we get to plug and put the power in front of the log. And we have log 7 plus 2 log, sorry about that, whoopsie, 2 log x minus log 3, and that's our answer. Next one. This one, when we're trying to solve exponential equations, our goal is to try to get the bases to be the same. So I can rewrite 9 as 3 squared. And I can rewrite 27 as 3 cubed. So now I would have a matching base situation. Before I deal with that, though, I'm going to take care of my exponents. I would distribute in this case. It's kind of a weird distributing, but 3 to the 4x minus 6 and 3 to the 3x plus 15. And then my bases are the same, so I essentially cancel them out. I'm just going to get rid of them and just solve for the exponents here. So set those exponents equal to each other. And then I would subtract 3x from both sides. I get x minus 6 equals 15. Add 6 to both sides. I get x equals 21. And on we go. Number 14, to simplify the expression. When you see fractions with lots of complicated x's and numbers, polynomials, typically what we look to do is factor, factor, factor. I'm actually going to start, before I factor on this one, I'm going to start by fixing the division. With fractions, we don't divide. Instead, we show that as multiply by the reciprocal. And here, this is the one where I told you guys to fix the, on your study guide, it might have said minus 18. Make sure it does say plus. That was a typo. All right, so now that it's multiply, I'm going to factor. The numerator on the first fraction, multiply to make 10, add to make 7. The numbers that do that are 5 and 2. So x plus 5 and x plus 2. Then the denominator factor, multiply to make negative 12 and add to make negative 4. The numbers that do that are negative 6 and 2. So x minus 6 and x plus 2. Then over here, factor, multiply to make 18, add to make negative 9. Numbers that do that are negative 3 and negative 6. So x, minus 6, that's fine, and x minus 3. Then in the denominator, can't factor the x minus 3. Then we look for our stuff to cancel. So cancel, 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 cancel. I'm left with x plus 5. Then graphing for this one, because it is a multiple choice test, you don't have to graph it by hand. The key really is to know what the asymptotes are, and those come from your h. Whoa. From your h, so h equals negative 2. I'm sorry, positive 2, excuse me. H is the opposite of what it appears. So h would be positive 2. And then k equals 3. So knowing that h always goes with x, this is the asymptote would be x equals 2, and that is vertical. So go over to x equals 2, and there's your vertical asymptote. And then k equals 3, this one would be for the asymptote. Since k always goes with a y, this is y equals 3. So there's your asymptote at y equals 3. Then for a rational expression, the graph essentially does a curvy thing like this, does the boomerangs, and that's all you need to know for the test, is you need to know the shape and where the asymptotes are. All right, next one. Then this one we have like denominators, so all we have to do is subtract. In this case, it is as if I have parentheses here, so I'm going to need to distribute. So first, I'm going to write this as one big fraction with that common denominator, so 3n plus 11. Then distribute my negative minus n minus 6, and then combine like terms. So 3n minus n is 2n, 11 minus 6 is 5. Then I have 8n minus 16. Double check you can't factor specifically the numerator, which we can't. So since we can't factor the numerator, we are done. On to number 17. This one, sorry, see if I got that. Nope. Let's go back to 17. Okay, number 17, when we multiply like bases, we're going to add those exponents. So I'm doing 3/4 plus 2/5. In order to add those, I need a common denominator. For 4 and 5, that denominator is going to be 20. So I'm going to rewrite each fraction so it has a denominator of 20. So the first fraction, I would multiply top and bottom by 5. So I get 15 over 20. Second fraction, multiply top and bottom by 4. So I get 8 over 20. Add them together, I get 23 over 20. But be careful, that's only the exponent. So it would be x to the 23 over 20. Final answer. All right, then we have 5 to the x equals 17. This one, another exponent problem. If you can make the bases match, great. 5 and 17 don't have a whole lot in common. So instead, if I can't make the bases match, I'm going to log both sides. And then from there, I can log. So move the x in front. And then to solve for x, this says x times log 5. So I would divide by log 5 on both sides. And then I would put that into my calculator. I don't remember the answer here. I think it's 1.67 maybe, or 76, something like that. I'm going to erase that because I'm not 100% sure and I don't have a calculator with me. It's 1 point something. But that's how you would get your answers, to put that in your calculator. All right, number 19. Another graphing one. Again, you just have to identify the graph. So, whoopsie, knowing that h and k is really important. So h would be 1, k would be 2. On this kind of graph, this is going to give us a point on the graph for a cube root. So that's going to give us what I call the turning point. So it is at 1, 2. So over 1, up 2. And for a cube root graph, it looks kind of like the cubic squiggle, but it starts low in this way and then curves high like that. But that point is kind of where it changes directions. So as long as you know the shape of the graph, you should be able to find it based on just that one point. All right, number 20, again, lots of fractions and x's and polynomials, all kinds of stuff. So we're going to factor, factor, factor. So the first fraction, numerator, can't factor it, so x plus 6. Denominator, this is difference of squares. So I have x squared and minus 25 is the same as 5 squared. So x plus 5 and x minus 5 is how we factor that. The second fraction, the numerator, multiply to make 40 and add to make positive 3, positive 3. And so when I do that, let's see, 8 and 5, negative 40, there we go. So it looks like 8 and negative 5. So x minus 8 and x plus 5. Then the denominator, multiply to make 16 and add to make 10. Looks like 2 and 8. There. So x plus 2 and x plus 8. Then look for things to cancel. The 8's cancel. The plus 5's cancel. And I'm left with x plus 6 over x minus 5 and x plus 2. That's all for part 1, and that's all I'm doing tonight. If you want to check the 2 that I didn't do the calculations, the answers are up on PowerSchool for that, so you can check the work there. Sorry I didn't have the answers handy. Good luck. We'll see you guys tomorrow.